Okay, so we all know AI is getting mind-blowingly powerful, right? But here's the thing. It can also be crazy expensive and super slow. So what if we could have the best of both worlds? What if we could build AI that's not just powerful, but also, practical? Let's dive into how we can get AI that's both fast and affordable. So let me ask you this. Is your AI just too expensive? Look, if you're building anything with AI, you probably know exactly what I'm talking about. Every single API call adds up, and those really complex queries, they can take forever to come back. For anyone trying to scale a product, this is a huge, huge headache. And this really gets to the heart of the problem. It's this big trade-off, right? On one side, you've got these super powerful models, they're geniuses, but they're also slow and they cost a fortune. And on the other side, you have these fast, cheap models that are great for simple stuff, but just can't handle the heavy lifting. Using the best, most expensive model for every single little thing, it's like using a sledgehammer to crack a nut. It's just total overkill. So what's the solution then? Well, there's a really smart strategy for this, and it's called resource-aware optimization. It's a bit of a mouthful, but the idea is simple. It's all about making AI agents smart about how they use resources. So instead of just blindly jumping on a task, they actually stop and think. They look at the cost, the time, the computing power involved, and then they figure out the most efficient way to get the job done without blowing the budget. Okay, so check this out. Here's what that looks like in practice. A user sends in a prompt, right? But, and this is the key part, it doesn't just go straight to some big, expensive model. No. First, it hits this intelligent agent that acts like a smart gatekeeper. This little agent takes a look at the request, checks the budget, and only then does it decide the best, most efficient way to get you an answer. So, how does this actually work? Well, one of the most popular and, frankly, effective ways to do this is with a team of two specialized agents. Think of them as a dynamic duo. Let's meet them. We've got the router and the critic. All right, first up, let's talk about the router agent. The best way to think about this one is as a smart traffic cop for all your AI queries. Its entire job is to look at the incoming traffic, the prompts, and direct each one to the perfect specialist for the job. No traffic jams, no wasted trips. Let's make this real. Imagine you're building an AI travel planner. If a user asks, hey, plan me a 7-day trip to Italy, that's complex, right? It needs a lot of thought. So the router would send that to a powerhouse model like Google's Gemini Pro. But what if the next query is just, what's the price of a flight to Rome on Tuesday? That's a simple lookup. The router knows this and sends it to a much faster, cheaper model, like Gemini Flash. And the best part? The user never sees this happening. It's all automatic. So how does the router do its job? It's actually a pretty straightforward 3-step process. First, it classifies the query. It asks, is this a simple question or does this need some serious brain power? Step 2, it routes that query to the perfect model for that category. And finally, step 3, that chosen model gets to work and generates the response. That's it. It's the simple little dance: classify, route, generate. And here's a great example from the OpenAI ecosystem. Let's say you ask a simple question, like, what's the capital of Australia? The router is smart enough to know that doesn't need a supercomputer. It'll send that to a fast, cost-effective model like GPT-4o Mini. But if you ask it to analyze a complex legal document, it knows to route that to the more powerful GPT-4o. This kind of intelligent triage, it's a game changer. It saves a ton of money and a ton of time. Okay, but wait a minute. What happens if the router messes up? Or what if the model it picks gives a kind of meh answer? Well, that's where the second member of our duo comes in, the critic agent. You can think of the critic as the system's built-in quality inspector. Its job is to look over the router's shoulder and check the final work to make sure everything is top-notch. And we can actually get a peek behind the curtain at its job description. This is from its actual system prompt. It tells the agent, and I'm quoting here, your primary function is to meticulously review and challenge information, guaranteeing accuracy, completeness, and unbiased presentation. So you see, this is way more than just a spell checker. It's a true quality assurance partner built right into the system. But here's where the critic really shines. Its true power is in how it makes the whole system smarter over time. Yeah, it catches errors, and that's great. But the feedback it provides actually helps train the router to make better and better decisions in the future. It flags when a cheaper model could have been used, which saves money. It creates this awesome feedback loop that just drives constant improvement. Okay, I know what you might be thinking. Building this whole router critic system from scratch sounds really complicated. And you're not wrong. But the good news is you probably don't have to. These ideas are already being built directly into tools that developers can start using today. A great example of this is a service called OpenRouter. Think about it. Instead of trying to manage and juggle APIs from dozens of different AI companies, OpenRouter puts hundreds of different models all under one roof, accessible through a single API. This makes it the perfect playground for a resource-aware strategy, because all the tools you need are right there in one box. And guess what? OpenRouter has this smart routing stuff built right in. They have an auto mode that basically does all the work for you. It just automatically picks the best model for whatever prompt you give it. And then they have something called fallback mode, which is fantastic for reliability. You just give it a list of your preferred models, and if the first one fails for some reason, it automatically tries the next one on the list. No downtime. But here's the thing. As cool as dynamic routing is, it's really just the tip of the iceberg. It's just one tool in a much, much bigger toolkit for building these incredibly efficient, resource-aware AI systems. I mean, there are all sorts of other clever techniques. Take contextual pruning, for example. This is where the system intelligently summarizes a long conversation history. That way, you're not sending the entire novel back to the AI with every single turn, which saves a ton on tokens. Or there's graceful degradation, a fancy term for making sure your app doesn't just crash when it's low on resources, but instead keeps working in a more limited way. See, every one of these techniques is about one thing, being smarter. Okay, so we've gone through a lot of these concepts. Let's bring it all back home. Why does any of this really matter to you? And more importantly, when should you actually be thinking about using these kinds of patterns? Well, here's a good rule of thumb. You should absolutely be looking at these patterns if you're working with a tight budget for your API calls, or if you're building an app where speed is absolutely critical. No one likes a laggy interface. It's also key if you're trying to run AI on something with limited power, like a phone or an edge device. Basically, it's for any time you need to find that perfect programmatic balance between quality, speed, and cost. And that right there is really the main takeaway. The most powerful AI systems of the future aren't just going to be the ones with the most raw intelligence. No, they're going to be the ones with efficient intelligence. The ones that are smart enough to get the absolute most bang for their buck, resource-wise. Which kind of leaves us with a pretty fascinating question to chew on, doesn't it? As AI gets more and more powerful, is it possible that the smartest systems will actually be the ones that have figured out when it's better not to think so hard?